Okay, so again we have that same situation. Things are lined up. This is what it means to solve by elimination, because we're eliminating one of the variables. And neither one of these add up to 0. So again, I need to manipulate one of the equations. So I'm going to multiply this bottom one all the way through by 5 so that the x's will drop out. So this becomes, I'm actually going to rewrite the whole thing because I like to see them next to each other. Okay, I'm going to distribute this 5, so I have 5x minus 10y equals 10. I add these together and I get negative 7y equals, add these together, I get 21. Divide by negative 7 and I get y equals negative 3. So now I just need to plug it in. I'll plug it into this one. X minus 2 times y, which is negative 3, equals 2. So x plus 6 equals 2. Subtract 6, x is negative 4. So my answer is negative 4, negative 3. All right. I hope you got that. And I hope your brain is clicking and you're going, oh yeah, I remember how to do this. Okay, so there are 3 different outcomes that we can get when we are doing systems of equations, when we've got 2 equations, 2 unknowns. One is what we were just doing. X marks the spot, right? We also have another situation where they're parallel to each other. And these never intersect, right? So in this one, there's one solution. In this one, there are no solutions because they never cross each other. I know this one's kind of weird, but this is actually a line with the same line right on top of it. So where does a line intersect with a line when they're right on top of each other? Everywhere. So this has infinitely many. They're the same. Okay, so I just needed to cover that. All right, so here's a question. We've done the 2 equations with 2 unknowns. Can we solve this? The answer actually is no. We just don't have enough information, okay? But can we solve this? And the answer is yes. If we have 3 unknowns, x, y, z, and we have 3 equations, it's a 3 by 3 system, and we can do that. And this gets a little complicated. Be patient. I just gave you 2 of these equations to do tonight, 2 of these problems. But relax and just work your way through it. Be very, very deliberate. Okay. Okay, this is what I was just talking about. If the solution of a system of 2 equations with 2 unknowns is x, y, like we see, then the solution of a 3 by 3 equation is x, y, z. And so we'll see that when we do that, or when we do some of those problems. Okay, so just like with the 2 by 2, we also have the same situation with the 3 by 3. Okay, this is what it would look like if there's exactly one solution. This is, they cross and then they cross another way. Okay, you got to think of this in terms of an x, y, I don't know how to show you on the camera, but it's 3D, x, y, z coordinate plane. Okay, this is when none of them, and that's because none of them overlap each other. There are no lines. Okay, this one's a point. This one, a couple of them might have, the same lines in them, but not all 3 of them have the same line. This one is if all three of these planes intersected with each other and their solution is a line. It's every single one of these. And so that one goes on forever. Well, these are kind of cool pictures. Okay, so this is a lot. I put it as an attachment, And I'm not gonna read it, but I put this as an attachment with this lesson so that if you need to, you can work through it step by step. So hopefully that will help if you use that. Okay, so let's look at this example. It really looks horrible, I know, but you can do this. All right, so the first thing that we're going to do is we are going to take a 3x3 system and make a 2x2 system. And sometimes what I'll do is I'll think of this in 3 categories. Okay, the solution is going to look like X, Y, Z. This is where I'm going to solve the 2x2 equation. This is where I'm going to whittle this down to just 2, and I'll show you how you do that. So you pick 2 equations. I'm going to pick these first 2. I'm going to rewrite them. 3x plus 2y minus z equals 8. And then I've got negative 3x plus 4y plus 5z equals negative 14. Okay, I know I've only got 2, but what I'm going to do is I'm going to get rid of one of these variables, okay, and by adding like we did before. And if I look, the 3x's just naturally drop out by themselves. Okay, so I add this up and I have 6y plus, this is going to be 4z equals negative 6. There's one of my 2x2 equations. So I'm going to write that over here. 6y plus 4z equals negative 6. Now I need to pick 2 different equations. I'm going to erase this because I don't have enough space. Okay, but that's how I got that first one. Okay, so I did the first 2, and like I said, it doesn't matter really what you pick. I think I'm going to pick the first one and the last one. So I'm going to rewrite those. And this is x minus 3y plus 4z equals negative 14. Now the trick to this one is that you have to get rid of the variable that you got rid of for this one. Okay, so we've got to get rid of the x. So in order to do that, actually I'm going to use a different color. I'm going to multiply this whole thing through by a negative 3 so that these x's will drop out. So I'm going to distribute this. I've got negative 3x plus 9y minus 12z equals, what's 14 times 3? 42? Yep, positive 42. Okay, so this is my new equation. You can't erase it on yours unless you want to, but I'm going to erase this. Okay, now I'm going to add these together. The x's drop out. This is 11y. This is minus 13z equals 50. Okay, so now I'm going to bring this over here. And here is my new system, and we just did these, so you know how to do these. Okay, I need to finish this problem on the next, I hate to do that, but I've got to finish it on the next video.